Right now, at this exact second, there is a version of you who made every different choice you have ever faced, and physicists at some of the most prestigious institutions on Earth believe that version is just as real as you are. Not metaphorically. Physically. Actually real. And that is just the opening act. Fact number 1. The multiverse is not science fiction, it is the default prediction of inflation theory, accepted by NASA and published in peer-reviewed journals. Here is where most people's brains short-circuit. The multiverse was not invented by Marvel Studios. It was a mathematical consequence that physicists did not want and got anyway. In 1980, MIT physicist Alan Guth proposed cosmic inflation, the idea that the universe expanded at incomprehensible speed in the first 10 to the power of -32 seconds after the Big Bang. The math worked perfectly. NASA's WMAP satellite confirmed the fingerprints of inflation in 2003. But here is the thing nobody mentions: inflation, once it starts, almost never stops everywhere at once. Different regions of space stop inflating at different times, each one becoming a separate universe with potentially different physical laws. This is called eternal inflation, and it is the standard cosmological model taught at Harvard, Cambridge, and Caltech. Stanford physicist Andre Linde, one of the architects of inflation theory, said in a 2017 interview, "The multiverse is not a hypothesis, it is what the equations demand." Let that sink in. Visual note: animated infographic showing a branching diagram of bubble universes separating from an eternal inflation field. Use cool blues and whites, academic style. Fact number 2. There are at least 4 scientifically distinct types of multiverse, and they get stranger at every level. This one stops people cold because they assume multiverse means one thing. Cosmologist Max Tegmark at MIT spent years categorizing the different multiverse types that separate scientific theories demand, and in 2003 he published a landmark paper in Scientific American laying out 4 distinct levels. Level 1. Regions beyond our observable universe with the same physical laws, essentially infinite space containing infinite copies of everything. Level 2. Bubble universes from eternal inflation with different physical constants, gravity might be stronger, electrons might not exist. Level 3. The many worlds interpretation of quantum mechanics, where every quantum event spawns a new universe branch. Level 4. And this is the one that makes physicists go quiet: a multiverse where every mathematically consistent structure exists as a physical reality. Tegmark calls this the mathematical universe hypothesis. Not universes like ours. Not universes with matter and energy. Any universe that can be described by consistent mathematics exists. Physically. Somewhere. The number of universes that describes is not a big number. It is literally uncountable infinity. Visual note: a 4-level pyramid infographic, each level color-coded differently, with brief bullet descriptors, clean, academic design. Fact number 3. Quantum mechanics essentially requires parallel universes to make its own math work, and Hugh Everett proved it in 1957. Okay, brace yourself, because this fact broke a physicist's career and turned out to be right. In 1957, Princeton physicist Hugh Everett III submitted his doctoral thesis proposing something radical: that the wave function, the mathematical description of a quantum particle's possible states, never actually collapses. In standard quantum mechanics, a particle exists in superposition, meaning it is in multiple states simultaneously, until you measure it, at which point it picks one. Everett said, what if it picks all of them? What if every possible outcome of every quantum measurement actually happens, just in separate, branching versions of reality? His advisor, John Wheeler, made him water the idea down before publishing. The physics establishment largely ignored him. Everett left academia, became a defense contractor, and reportedly drank heavily. He died in 1982, never seeing his theory vindicated. But here is the jaw-dropper: by the 1990s, physicists including David Deutsch at Oxford, who would go on to pioneer quantum computing, declared Everett's many-worlds interpretation the most mathematically consistent framework for quantum mechanics available. A 2013 survey of physics conference attendees found that many worlds was the most popular single interpretation of quantum mechanics among professional physicists. The man was right. The universe branches. Every single quantum event. every moment. Including right now. Visual note, a branching tree diagram showing a single quantum event splitting into multiple timelines, monochrome with color highlights at each branch point. Fact number 4, our universe may have already been hit by another universe, and scientists found the bruise. This is the one that makes people grab the person next to them. In 2010, cosmologists Stephen Feeney, Matthew Johnson, Hiranya Piras, and Andrew Pontzen published a study analyzing NASA's map of the cosmic microwave background, the faint afterglow of the Big Bang that permeates all of space. They were looking for something specific, the predicted signature of a bubble universe collision. In eternal inflation theory, bubble universes can physically collide, and that collision should leave a circular cold or hot spot imprinted on the CMB. What did they find? 4 anomalous circular patterns in the CMB data that match the theoretical collision signature with statistical significance. 4. Potential universe bruises. The scientists were careful. They published their findings, noted the patterns were consistent with collisions but not yet definitive proof, and called for more data. The European Space Agency's Planck satellite subsequently mapped the CMB in even higher resolution. The debate continues in the scientific literature right now. But the critical point, this is not a thought experiment. Scientists built a specific, testable prediction and found candidate evidence in real observational data. The multiverse left a mark. And we can see it. Visual note, an academic-style color map of the CMB, the standard NASA oval projection with temperature variations shown in blue to red spectrum, with 4 highlighted circular regions indicated by white dotted outlines. Fact number 5, string theory's landscape problem accidentally created 10 to the power of 500 possible universes, a number so big it has no name. Here is where the numbers become genuinely incomprehensible. String theory, the leading candidate for a theory of everything, developed through the combined work of physicists including John Schwartz, Michael Green, and Edward Witten across the 1970s through 1990s, describes the universe in terms of tiny vibrating strings of energy existing in 10 or 11 dimensions. When physicists calculated how many different stable configurations of those extra dimensions were possible, they got a number, 10 to the power of 500. Write out 10, then write 500 zeros after it. The total number of atoms in the observable universe is only 10 to the power of 80. The string theory landscape, as physicist Leonard Susskind at Stanford named it in a landmark 2003 paper, implies that each of those 10 to the 500 configurations could be its own universe, each with different physical laws, different particle masses, different fundamental constants. Some would have no atoms. Some would collapse in a nanosecond. A tiny fraction would be like ours. Susskind argued this landscape, combined with the anthropic principle, the idea that we can only exist in a universe compatible with our existence, actually explains why our universe's constants seem perfectly tuned for life. Not because they were designed, but because among 10 to the 500 universes, some will be habitable, and we are, by definition, in one. Nobel laureate Steven Weinberg had actually predicted a specific value for the cosmological constant using this exact logic in 1987, a decade before observations confirmed his prediction in 1998. The landscape is not a bug in string theory. Susskind argues it is the most important feature. Visual note, a vast 3D landscape visualization rendered as an academic topographic map with peaks and valleys representing energy configurations, labeled axes, clean color gradients, no photorealistic imagery needed. Fact number 6. Nobel Prize winner Roger Penrose believes he found evidence of a universe that existed before the Big Bang, suggesting our multiverse is cyclical. Now we hit the fact that splits the physics community right down the middle, which makes it even more fascinating. Sir Roger Penrose, Oxford mathematician, collaborator of Stephen Hawking, winner of the 2020 Nobel Prize in Physics, has spent years developing a theory he calls conformal cyclic cosmology, or CCC. His proposition, the Big Bang was not the beginning of everything. It was the end of a previous universe. In CCC, when a universe expands so far that all matter eventually radiates away into photons, the universe becomes, mathematically, conformally equivalent to a new Big Bang, meaning the geometry of an infinitely large, cold, empty universe is mathematically identical to the geometry of an infinitely small, hot, dense singularity. One becomes the other. A new universe is born. And crucially, this cycle has happened an infinite number of times before us, and will happen an infinite number of times after. Penrose and his colleague Vahe published findings in 2010 claiming to have detected concentric circular patterns in the CMB, remnants, they argued, of massive black hole mergers from the universe that preceded ours. The claim is contested, other researchers dispute the statistical significance. But this is Roger Penrose, 2020 Nobel laureate, making a specific, testable, published claim about pre-Big Bang existence. That is not fringe science. That is one of the greatest mathematical minds alive saying, there were universes before ours, and I found their footprints. Visual note, a circular diagram showing the cycle from heat death of one universe transitioning into the Big Bang of the next, rendered as a smooth loop with color temperature shifts from deep blue cold to white hot singularity. Fact number 7, the fine-tuning problem, the fact that 26 physical constants are calibrated so precisely that any tiny change destroys all possibility of life, is one of physics' biggest unsolved problems, and the multiverse is the leading scientific answer. This fact will genuinely make you stop and stare at the wall for a moment. Our universe runs on approximately 26 fundamental physical constants. The speed of light. The gravitational constant. The mass of an electron. The strength of the strong nuclear force. Here is what makes physicists lose sleep. If the gravitational constant were stronger by just 1 part in 10 to the power of 60, that is 1 part in a billion trillion 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 trillion, the universe would have collapsed back on itself before a single star formed. If the cosmological constant, the energy density of empty space, were larger by a factor of 10 to the power of 120, the universe would have expanded so fast that no matter could ever clump together. No galaxies. No stars. No planets. No chemistry. No life. Physicist Paul Davies, in his book The Goldilocks Enigma published in 2006, catalogued these constants exhaustively. Cambridge cosmologist Martin Rees, in his 2000 book Just 6 Numbers, showed that 6 specific constants alone completely determine whether a life-permitting universe can exist, and all 6 are set to jaw-dropping precision in ours. There are 3 possible explanations scientists take seriously: 1. Incredible cosmic coincidence, 2. A designer, 3. A multiverse so vast that all combinations of constants exist somewhere, and we are in the life-compatible one by definition. The majority of physicists who work in cosmology and quantum gravity choose door number 3. The multiverse does not just explain the origin of universes. It explains why we exist at all. Visual note, an infographic of 6 key physical constants displayed as tuning dials, each with a tiny highlighted zone representing the life-permitting range against the vast scale of possible values, like a radio dial with a pinpoint signal in static. Fact number 8. The most shocking implication of the many worlds multiverse is that you are functionally immortal, and physicist Max Tegmark has publicly done the thought experiment. We have saved the most mind-bending for last, and this one comes with a scientific name: quantum immortality. Here is the logic, and it is airtight within the many worlds framework. In many worlds, every quantum event branches into all possible outcomes. Your survival in any given moment depends on countless quantum processes, the specific behavior of particles in your cells, your neurons, your environment. Every moment that you could theoretically die due to a quantum-level accident, the many worlds interpretation says a branch exists in which you do not. From your subjective point of view, from the only perspective you can ever experience, you always survive into the next branch. Because in the branches where you do not survive, there is no subjective perspective left to experience the outcome. This concept was formalized by philosopher David Lewis and physicist Hans Moravec independently in the 1980s and 1990s. In 1998, Max Tegmark, the same MIT cosmologist from fact number 2, published a paper in the journal Foundations of Physics Letters explicitly analyzing quantum immortality as a logical consequence of many worlds, and discussed what it would mean for a physicist to test it. He did not recommend testing it. But he published the math. The implication, from your subjective experience, you will always find yourself in the branch where you survived. You may age. You may suffer. But in the branches where many worlds is true, something that functions like your consciousness threads forward through the surviving branches indefinitely. Physicists debate fiercely whether this logic holds. But the math is real, the papers are published, and the journals are peer-reviewed. Reality, it turns out, might be stranger than anyone was prepared to admit. Visual note, a branching flowchart showing subjective experience always threading to surviving branches, with non-surviving branches clearly grayed out, academic diagram style, no graphic content, purely logical flow visualization. So here is where we are. The multiverse is not a movie plot. It is the mathematical consequence of our best-tested cosmological theory. It is what quantum mechanics looks like when you take its equations seriously. It is the only explanation for fine-tuning that does not require a miracle. It is supported by Andre Linde, Max Tegmark, Roger Penrose, Leonard Susskind, David Deutsch, and a 2020 Nobel laureate. And it predicts that right now, an infinite number of versions of you are watching a different video, making a different choice, living a completely different life, and every single one of those versions is, by the best available physics, just as real as you are. If this rewired how you see reality, and let's be honest, it should, subscribe to Moonlit Minds for daily mind-blowing facts that will change how you see the world.